Hey guys, I'm Aidette.
I'm Lily,
And I'm Gabriela.
and today we're going to learn about square root functions.
Here we have the parent function for the square root function. The equation is y equals the square root of x. As you can see in the table, the y values are each the square root of the x value. For example, the square root of 4 equals to 2, and the square root of 9 equals to 3. You start at the origin, and if there's any transformations, each transformation starts from the origin as well. There are multiple transformations that can occur. For a translation up, it'd be the square root, and then out of the square root, it'd be plus whatever number. Translation down is the square root, and then out of the square root, it's minus whatever number. For vertical stretch, there's a number before the square root of x, and for vertical compression, there's also a number before the square root of x. For the reflection over the x-axis, there's a negative sign before the square root of x. For translation right, inside of the square root would be x minus whatever number. For translation left, it'd be the square root of x, and inside of the square root as well would be plus a number. Horizontal stretch would be inside of the square root, it'd be a number of x. And for horizontal compression, it'd be the same thing as horizontal stretch. Inside of the square root, it's a number and then x. For reflection over the y-axis, inside of the square root, there'd be a negative x.
For this example, fx equals square root of x plus 4. To be able to graph this function, you would first place negative 4 on the x-axis as whatever is within the square root means the opposite. So since it's a positive, it would be a negative. But since you need at least 3 points to be able to graph a function, you would like to also solve x-intercept and y-intercept. To figure out the x-intercept, you would make y equals 0, so 0 equals square root of x plus 4. To solve, you would cancel out the square root by the power of 2 and solve normally as if it were to be a linear function, and so it will be 0 equals x plus 4. Once solved, it will equal x minus 4. To figure out y-intercept, you will make x equal 4, so you would solve it f f0 equals square root of 0 plus 4. So you will first add 0 plus 4 equals square root of 4, and what square root of 4 equals 2, so f of 0 equals 2, and that will be your y-intercept. Once placed, you will use the parent function rule of involving maximum. To figure out maximum and minimum, normally your equation would give you a restriction. So for this one, it gives you a restriction of 3 greater than or equal to x greater than or equal to 8. Those 3 and 8 will be your restrictions for your square root function. To figure out minimum, you would place the lower value, or the one graph is your smaller value. So for this one, it's f3 equals square root 3 minus 3 minus 1. So first you would subtract 3 minus 3 equals 0. If when square root equals 0, so you will just be left with negative 1, which will be your minimum. For your maximum, you would place a greater value, which for this equation it will be f8 equals square root of 8 minus 3 minus 1. So you would first subtract 8 minus 3, which equals square root of 5. But since you can't square root 5, you would just leave the equation alone.
Steps to solve radical equations. First thing you want to do is isolate the square root. The second thing you want to do is square both sides. Then you want to solve, and then if it's a quadratic equation, you set it to equal 0, and if it's linear, you equal the variable to a number. And then fourth, you check. Solving the square root. Now when they solve the square root, they first isolate the square root by changing it into a square root function, and then They square both sides in order to cancel the square root. And from there, they solve, which in this case, it's a linear function. So they equal it to the variable to a number. And then they check their work in the blue. 7 steps you want to follow when solving a radical equation when both radicals can be isolated. Now, first thing you want to do is isolate the radical, and then the second step you want to do is square root both sides. Then you want to combine like terms, isolate radical terms, and then square root both sides. Solve each equation following the quadratic and linear rule, and then at the last and then the last step is to check all your work. As you can see, both there are two radicals and you can't isolate both of them. So first thing you want to do is you want to isolate one radical. As you can see, they isolated one radical and then they squared both sides in order to cancel out the square root, but they couldn't cancel out both, so they're left with one. And then they combine like terms to dumb down the equation, and then they isolate radical terms, as you can see right there, and then they square root both sides again in order to solve following the quadratic and linear rules. And then, as you can see in the blue, they check their work.